As agriculture grows smarter, the tools beneath our soil are changing. Soil sensors and monitoring systems are the quiet engines behind modern precision farming. But when these devices reach the end of their life, a new challenge emerges: how to recycle them responsibly. Today's farmers rely on data as much as rainfall. Sensors track soil moisture, pH, temperature, and salinity in real time, guiding every decision from planting to irrigation. These compact technologies help conserve water, reduce waste, and improve yields. Yet, as farms adopt more of them, we must also confront the environmental costs of the devices themselves. The question isn't just how they help us grow, but what happens when they stop working. Unlike tractors or combines, these devices are small, but there are thousands of them. Each farm may have dozens or even hundreds of units spread across its land. Built to resist weather and UV damage, they are tough to take apart or recycle. When they fail, entire systems may be replaced at once, creating a surge of small but significant e-waste. Without the help of licensed recyclers, most of these units are left in storage, abandoned, or tossed away. Each sensor contains a complex mix of materials and risks. The circuit boards hold gold, cadmium, and lead, valuable but toxic if mishandled. Lithium batteries can leak, ignite, or contaminate the soil they once monitored. Plastic casings and adhesive-sealed housings resist both weather and recycling. Only licensed recyclers have the specialized equipment to recover materials safely, protecting both workers and the environment. Even though they're built to survive the elements, many sensors don't last long. Batteries run out, seals wear down, and software updates make older devices incompatible. Often, they're discarded not because they're broken, but because they can't connect to new systems. The cycle of replacement turns useful tools into waste faster than we can process them. We need smarter design, technology that endures, adapts, and evolves with the farms it serves. The problem isn't just disposal, it's design. Most sensors aren't built to be fixed or reused. One broken part means the entire unit is scrapped. But this can change. Modular construction would allow easy replacement of batteries or parts instead of full disposal. Repairable, upgradable sensors mean fewer devices in landfills and more years of reliable service. Sustainability begins on the engineer's desk, long before a sensor touches soil. The solutions are already within reach. We can design with recycling in mind, using standardized parts and recyclable materials. We can implement battery return and replacement programs to prevent hazardous waste. We can create rural collection points to recover used devices at scale. And through education, we can empower farmers to take part in sustainable disposal practices. With licensed recyclers as partners, every device can have a responsible afterlife. Sometimes the best way to reduce waste is through software. When sensor data is compatible across systems, devices stay relevant longer. Open standards and firmware support can keep older models useful for years. By making data portable, we break free from forced obsolescence, saving both money and the environment. Digital sustainability is just as vital as physical recycling. Technology and sustainability don't have to compete. They can work together. Farmers, manufacturers, and licensed recyclers must join forces to design systems that protect the planet while feeding it. When sensors are built for repair, reuse, and recovery, we move toward a true circular economy. Smart farming should mean more than efficiency. It should mean accountability, because innovation that respects the earth will always yield the best harvest. To recycle your farm's electronic equipment safely and responsibly, reach out to EACR Inc. Together, we can build a cleaner, smarter future for agriculture, one device at a time. Smart farming must end where it began, with respect for the earth.